Okay, so we did question. Now we're on question 2. First of all, I need to know what the picture of this looks like. Not only do you need to know how to find an inverse by doing it the algebraic way, you need to be able to graph the original function so that you can reflect it across the line y equals x. It's really important that you understand the picture as well as the algebra. We're not going to be picking the most complicated things we can find, but we do need to be able to look at this and say, okay, what kind of parabola is that? Which way has it been moved? It has gone left. Okay, so that is left 6. So we're starting over here at negative 6, 0, right? Which way does it open, up or down? It opens up, right? It's got a positive 1 in front of it, so we know it opens up. That's the basic picture of what we're starting with. Now, because we talked about how the reflection would go across the line y equals x, I'm going to draw a nice little dotted line in here for y equals x. And we want to think about how that would look when we reflect it. So what's going to happen to the point negative 6, 0 when you switch x and y? Remember, that's what we talked about. First thing you need to do is switch x and y. So what's going to happen to that coordinate? 0, negative 6. Now, what you need to be able to do is look at that and then see a mirror image on the other side. I think it's probably easier to do this part first. Find that mirror image on the other side. I think mine's a little bit drastic, to be quite honest. Something more like that. So what do you think is going to happen with this other one? Hopefully you realize that it's going to go down. Yesterday we did this folding idea. Can we talk about this idea where we took a piece of paper with a parabola on it? Yeah. Folded it, right? So we took that paper, folded it across, and we saw that if it was an up-opening parabola when we started, then when we did the reflection, it ended up being one that opened to the right. Now, typically when I graph those, I like to find a point that's on the blue line. But we didn't have any on the blue line, not very easily found. So we weren't able to do that. Okay, in fact, we couldn't find any on that particular one. Okay, now, that's what the picture is going to look like. And I'm going to ask, and we'll see how the algebra works out here. So first step, switch x and y. All right. So if we switch x and y, we've got x equals parenthesis y plus 6 quantity squared. All right, now what are we going to do to get y by itself? That's step number 2, is to get y by itself. So how do we handle getting rid of the square? Take the square root. Before I continue with this problem, I've got a different question for you, which is somewhat related, but kind of not related. In the box in the upper right, x squared equals 9. Can you tell me all of the values of x which would make that statement true? X squared equals 9. 3 is the most obvious answer, but it's not the only one, as Yoda would say. There is another, right? Negative 3, thank you very much. There's 2 answers. There's a plus 3 and a minus 3. So in those solving situations, because you and I both know that you would be taking the square root of both sides of that, you would have to answer plus and minus 3 for that one. Well, you're taking the square root here also in a solving situation. So what's going to go out here in front of that square root? Thank you. What's going to go out in front? Plus and minus. There is only one thing left to do, and I'm trying to indicate it with that arrow. There's only one thing left to do. Get rid of the 6 by doing what? Subtracting, thank you very much. Which equation is correct? A, B, C, or D? That is choice C. You just don't want to forget the plus and the minus. Now, what part of my red graph, what part of the red graph is the positive square root? Look at that red parabola, that sideways opening thing. Which part of this thing is the positive square root? Is it the top half or the bottom half? Top, that's the positive. So what's this thing? It's the negative. The picture shows you that you need the plus and the minus. Okay. All right. Is the red one a function, yes or no? Is the red one a function, yes or no? That's a definite no, right? Fails the vertical line test. You need to be able to find the picture, otherwise you're not going to be able to answer the question. Okay? So please make sure you can use your notes to find those pictures. Understand we're using that whole switch X and Y thing. We're going to skip number 4 for right now because it's a lot like number 1. Okay? If we get a chance, we'll come back to it. Yes? Yes. Yep. Sure. Okay. All right, so number 5. Let's go to question 5. I need to know the basic shape of the original function. What is the gotta lock it in place. What is the basic shape of this thing? First of all, we know it's a parabola. Which way does it open, up or down? It opens up. What is the minus 2 doing on the outside? Moving it down. Thank you very much. So we have a parabola. It's kind of steep. Now, did I do the whole 1A, 3A, 5A thing, which you will be required to do on your test because we've already, we've done that graphing, right? Over 1 up 1A, over 1 up 3A, over 1 up 5A. We've done that. But that's not the point of this question, folks. I just need a basic shape. I don't need an exact shape. Just a basic shape. That's it. All right. Dotted line going through the middle. The y equals x thing going on there. What's going to happen to the 2 green dots? What will happen to the 2 green dots when we reflect across the line y equals x? They will stay exactly the same. They ain't moving anywhere. Okay. Now, what's this point down here? What is this point right here? 0, -2, which is also the y-intercept. That's true. You weren't wrong. I was just asking for more specific info. Okay? Where will that point end up on the new graph? Where will that point end up on the new graph? Well, remember, what are we doing with x and y? What are we doing with x and y? Switching them, right? So what is 0, -2 going to end up? -0. Exactly. Exactly. Good answer. -2, 0, so that's over here, right? So what's the shape going to look like? You've got the 2 points that aren't moving, right? And you knew that the vertex was at -2, 0, so you just basically connect the dots and make that shape across the line y equals x. Now let's do the algebra. Switch x and y. X equals 4y squared minus 2. All right. What do we do first? Add 2. Divide by 4. Excellent idea. I like it. Shoo, man, you are just flying. Tell me what I'm missing in my answer. Oops, sorry. Tell me what I am missing in my answer. Plus and minus, thank you very much. Remember, when you're in that solving situation and you're taking the square root, you've got to have the plus and the minus. Now, when you added 2, when that was your first step, you added 2. Does it make sense to you why I could have immediately gotten rid of B and D as possibilities? Yeah. You added 2 to both sides. How in the world are we going to get an x minus 2 in our answer? You're not. And we did end up with letter A. Okay, folks, the picture is answering the last question. Is the inverse a function? The green one. No. Fails. Vertical line test. Question 6. You know how to graph lines. Please do so now. Graph the line y equals 3x plus 5. Graph the line y equals 3x plus 5. Start with your y-intercept. Make sure you're starting with the y-intercept and not an x-intercept, okay? Start with the y-intercept first. So, find 5. You don't have to do any algebra right now for number 5. Unless you're trying to copy down what we did on this one. Oh, well, you copied down what we had. Here, let me scroll it back for you, and I'll freeze it so you can see it. Okay. It still might, because you stepped out a little recording, you might want to go back. Get y-intercept 5, slope 3. Okay. Pick 3 points that are on that line. Pick 3 points that are on that line. 5, 0. No, 5, 0 is not on this line. 0, 5 is. Yep. 0, 5 is. Yep. What else? Pick something else. -2, -1. Yes. Pick something else. One more. 1, 8. Now, how do I change that to an inverse? What do I do with those coordinates? Switch x and y. Thank you very much. All right. So I've got 5, -1, and 8 over here, and 0, -2, and 1. So 5, 0. -1, -2, and 8, 1. Now remember, we talked about that whole line y equals x that runs through the middle. What's going to happen to the purple dot that's on the blue line? The purple dot on the blue line, that one right there. It's not going anywhere, which makes sense, and it matches all the ones you just told me. There is the inverse. The purple one is the inverse. Let's answer their question. Or I'll ask you the question. Is the inverse a function? It's not multiple choice, but okay. Just kidding. All right, yes. It is. It passes the vertical line test. Okay, you should be able to answer question 7. If you need to look up here for the blue and the red, look up here. Now, I need to figure out why that... It's x plus 5. Which way is the parabola moving? Left, right, up, or down? And I should use the correct color because they said that the original one was in blue. So this is being moved left 5. Any answer blank that does not have the blue one moved left 5. Some of you are ignoring me, and it really is going to affect you on Friday. Please don't do that. C is not even an option, thank you very much. Because the blue one has not been moved left 5. You can get rid of that one right away, so you really only have 3 to choose from. Okay, you got about 20 seconds to do so. Figure out which one fits the inverse criteria.
I don't think my person would be okay with it. I'm fine with it.
Okay, which one did we choose? You are correct. Several of you have told me B. All right, now if I zoom in on that one and take a look at that picture, what I'm looking for is, does it look like a reflection across this line? That's what I'm really looking for, and it definitely does. So the blue one's in the correct place, and it does look like a reflection across that. Now, I'm not going to try to trick you and make another picture like this one, but the red and the blue one are switched. I mean, number one, that'd be kind of dumb with a black and white copy, you know. But I'm not going to be, there's nothing as evil as that, okay?
Wait, so we will have stuff like this on it? Like, when it, okay, so when I mean something like this, like, never mind.
You will have problems
like
where you're...
stuff, but it just won't be color.
Yeah, I probably will have to somehow like do dotted lines on one and solid on the other.
Or you just print it and follow me to the outcome?
I would love to. I don't know if I can, but I'll figure something out.
Okay.
But yeah, you're right. There has to be something. Okay, question 8. For this function, find the inverse. Okay, this is involving a little bit more information, so we need to kind of walk through this one. All right, first of all, I need to know what the picture of this looks like. It's a square root function. We all know that the square root functions kind of look like that, but which way has it been moved? Right, left, up, or down? To the right, 4 units. 1, 2, 3, 4. Okay? We know it's looking something like this. What is this point down here at the bottom? That one's not 0, 4, but you're close. 4, 0. Good. Good, good, good. Okay, now, what is the domain of that function? Remember how, you really need to pay attention. This is ridiculous that I have to get after you so many times. Seriously? I mean, come on. People need to pay attention to this stuff because it's on their test on Friday. If you push all those values down onto the x-axis, how much of the x-axis would get covered? X is greater than or equal to what? 4. All right, what about the range? If you push them all up against the y-axis, it would be y is greater than or equal to what? 0. Thank you very much. Okay, now, we got that dotted line, dot, 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 y equals x running through here. Where does the point 0 or 40, doggone it, I think I gave away the answer. Where does the point 40 go on the inverse? 0, 4, that's right. So it's up here. So what's the picture look like? Hopefully you know that it looks kind of like that. It's got to be a mirror image on the other side of that line. It looks like half of a parabola. Okay? What's the domain of that one? The domain of this red one would be x is greater than or equal to 0. Right. If I slid all these points down onto the x-axis, what about the range? Push them all up against the y-axis. What would you get? Y is greater than or equal to what number? 4. Does that make sense, how you're starting at 4 and going up from there? Is there a connection or relationship between the domain and range of the original one, the green one, and the domain and range of the red one? What is the connection? They're flipped. Why the heck would they be flipped? Okay, now, if they switched, why does that make sense? Why does it make sense that the domain and the ranges are flipped? Because the x and y flipped. If you flip the x and y, of course the domain and ranges are going to flip. Now, folks, understand something. Well, here, let's get to the equation before I bring up that point. Okay? Answer the two multiple choice questions that you see right there with the information you've already written in your notes. Answer the two multiple choice questions that we have right there. What are the domain and range of the function? That's the original one. And what are the domain and range of the new one? Thank you very much. Are you writing stuff down so that when you go back to the test, you know what to reference? That's important. I want to help you. Yes.
I don't see it.
You know what? I should get. Football, I should just keep it up here, and people are like, can I get a pass? Okay. Alright, I'll stop moving this much. Okay, what did we choose for the first one? C. How about that second one, the inverse? D. Now, the algebra, because the very first thing in this question said, find the actual inverse equation. So we switch x and y. There's 2 steps to solving that. 2 steps. While I sign this pass, you do those 2 steps. I need to go down there, I think. I need to do okay. You have to get rid of the square root first before you add the 4. Okay? Okay, we got to get rid of the square root first. What are we doing to get rid of the square root? What are we going to do to both sides? Square it, right, exactly. You were right. Okay, now what? Add 4, okay. all of you would have gotten that, I'm sure. Right? Switch x and y, solve for y. Now, tell me what the picture of that looks like. Tell me what the picture of this looks like. What's the picture of x squared plus 4 look like? Y equals x squared plus 4. What's that look like? What shape is y equals x squared? Parabola, right? And what is the plus 4 doing to it? Looks like it's outside. Of 4. Okay? Guess what? That's not the graph of this. You showed me the graph at the beginning. See, we started out with this, right? You said it was a square root function. It had been shifted over 4 units to the right. Okay? And when you did the inverse, right, you reflected across the line y equals x. What'd you come up with? You came up with this thing, right? Some kids get the idea that when we do the algebra, that you end up with this shape right here. That's not true. If you start with this, how do you end up with this? It's like you created a whole bunch of points that don't exist. Right? If you start with this, all you're getting is the Statue of Liberty. Right? That's it. That's all you're getting. You're not getting the entire parabola. The reason I didn't have you do the algebra first is because I wanted you to see the picture. Because the picture explained exactly what you were going to get. And if you did the algebra first, I'm guessing you might have said, oh, the domain's all real numbers. No. Now, the good news for you is that they didn't even give you that as an option for domain. Okay, so that the red graph, is that a function? Is the red one a function? Sure is. Passes the vertical line test. So that answers that part. Okay, I am going to skip 9 for the moment, and 10 and 11, and I want to jump down to 12. I'll come back to 9 if I have time. The basic shape of this, y equals x cubed. Okay, I think my daughter in her school referred to it as the whip-de-doo. Other people, the squiggle. I'm not sure. That's y equals x cubed. That's the basic one. All right. Now, if we're going to look at the line y equals x that goes through it, and we're going to graph this thing, what's going to happen to that green dot, and that green dot? What's going to happen to those three? They're all going to stay exactly where they are. Why is my door open? Gee whiz. What's going to happen to this part of the graph? What's going to happen to that part when you reflect it across? Isn't it going to be just like right there? Now, follow the logic. Draw. Follow the logic. All you're doing is reflecting, reflecting, reflecting. That's the green one. The green one is the inverse. I bet you can answer the bottom question now. Is the inverse, the green one, a function? Does it pass the vertical line test? Okay, all right. Yep. Do you want me to erase the blue one just temporarily? Okay. So is the green one a function? Is the green one a function? I got one person that's confident. That's not enough. Does the green one pass the vertical line test, yes or no? What do you think? Can you pass a vertical line through the green one and hit 1 point at a time only? Yeah, you got to have that confidence in your mind to pass that vertical line through and say, yes, we're only hitting 1 point at a time. Now, to the actual algebra, we switch x and y. Now we need to solve for y. How do you get rid of a cube? Cube root. Whoa. Stop. Now, cube roots can handle something that square roots cannot. Thank you very much. Cube roots can handle negative numbers. For instance, what is the cube root of negative 8? What number times itself 3 times gives me negative 8? The answer is negative 2. You can't do that kind of stuff with square roots. Yes. I made that up. I've just picked a random perfect cube because I wanted to illustrate the point that a cube root function can handle negative numbers, which tells me that answer choice C is the biggest fake answer on that. Why? Because they slapped a plus and minus in front of it. You and I should know that it is answer choice D, because the cube root function can handle negatives. We don't need to worry about that whole plus and minus thing. Okay, let's go back to number 9. This is more practice of something we did earlier. A little bit different shape. So what's the original one look like? What's the original shape look like? It's a parabola. Good, good, good. Which way does it open, up or down? It opens down, right? So we know it's opening down. I should say opens down. What's the plus 3 doing? Moving the whole graph up 3. Okay? So that point right there is the point 0, 3. And we know that it's opening down. Alright, so here's my little y equals x. What's happening to the 2 purple dots when I do the reflection? They are staying exactly where they are at. The point 0, 3, where is it going to go to? It's going to go to 3, 0, right over here. Which way is this thing opening? Ah, good call. You told me the 2 points that were not going to change. I found the vertex by switching its x and y coordinates, and then I followed the picture by reflecting across that line. We started with this, and what did we end up with? Please don't do this. Please don't rotate. Rotating is wrong. Okay? It's a reflection. We ended up with this. That's what we're going for here. This part down here reflected and became that. This part over here swung over and became this. And that's how you get that shape. It's a reflection, not a rotation. Okay, so switch x and y. X equals negative y squared plus 3. Start solving. There's 3 things you need to do. save the square root to the very end. Now, remember, in the order of operations, you know, I don't know if they taught you the whole PEMDAS thing, you know, or please excuse my dear Aunt Sally, or yeah. So when you're solving equations, you go backwards through the order of operations. So the first thing, when you go backwards, the first thing you have to deal with is that plus 3. Then the next thing you have to deal with is the multiplication by -1. The very highest thing in the order is the square. So that's why you want to save it for the very end. Okay? So really, it's like you're trying to reverse everything. Solving is going backwards. Okay, so what do I do first? You subtract 3. Next, divide by -1. Now, one way that you could write that is -x plus 3 equals y squared. I notice in the answer choice that they give you, they didn't write it like that. They wrote it like this. Now there's somebody who's paying attention. That gives you the answer. But you're right, the last thing to do would be the square root function. And when we have the square root, don't forget that you have to have the plus and minus in front of it. Okay? We will finish up question 9 tomorrow. We will review. We will test Friday.